Now the recording has been started again. Anyway, sir, so we are good to go now.
Just give me a second.
Okay.
Okay, we are going to start now.
Yes, sir.
How is everyone? I hope everybody is doing well. Yes, in the last class, we had covered graph databases. And we had basically started learning and started covering Cypher, the programming language. The language, the query language. It's not a programming language, it's a query language to query the relational databases. And what we are going to do today is basically Uwais is going to take us to the next step and basically teach us how to, basically we did it using Neo4j just to learn Cypher. He is going to basically tell us how we are going to use this in Neptune, which is AWS version of graph databases, and it supports Cypher and other query language, two other query languages as well. Wes, over to you.
So let me share my screen first. Okay. So yeah, today what we are going to do is cover the step 45A, which you can found in our repository. Let me show. And in the repository, what we are going to do is covering the step 45A, Neptune with Cypher and the GraphQL. In the repository, you can find all the documentation related to the graph database, AWS Neptune, and all the articles. So you can.
Wes, could you please increase your voice a little bit?
Yeah, sir. Is it better now?
Little more.
Okay. Now does it better?
Yes, go ahead, please.
Okay, so in the repository, you guys can find all the documentation and the articles related to the GraphQL and AWS and Cypher. So what we are going to do is we will see the step 00 and step 01. In the step 00, we have built the Neptune with the Lambda, and in the step 01, we have created the code application with the AWS AppSync. In the first step, and the 00, in the Neptune Lambda, we are creating a query and the API with the API gateway. And in the second step, in the step 01, we will create a AWS AppSync with the AppSync API. Okay, so first we go there.
Uwais, sorry to disturb you. Here are two things. Just you need to increase the font size so people would viewability would be easier for their screen. This is, I guess, good enough. Can anyone suggest me that is it good enough, or we need to increase the font more? This is it, and
yeah, it's good.
That's good. Okay. So for the other people, if you can move back Uwais, one link, if you could click the full stack serverless SDK, URL star, yeah, please click here. I want to address you that at least everyone who are serious about implementing CDK, please download that code. Uwais, if you could click the code option, the code tab, yeah. So you can download at least zip if you are not going to clone using GitHub. So at least you can download that, and then step by step you can explore these codes in Visual Studio Code or whatever IDE you need to use for TypeScript. In most of the code examples, TypeScript is used as a language for developing CDK. So the two thing is very good. So it would be, I think, very essential for you that you have a code window also in your desktop. So please, while Awais is providing you a briefing about what we are going to do today, I'll request to download the code and open it in your own Visual Studio Code. So it would be easier to follow. I'm going to do the same. Over to Awais.
Thank you, sir. Thank you so much. I also share the link in the chat window. So
Yeah, the link for the code is shared. You just open the link and click the code and download the zip.
Yeah. Let me come back to the step 45 here. So in the documentation folder, you can find all the documentation related to the queries and related to the installation part. In the help, you can see there is a link for the Cypher SQL queries. So you guys can see there. And there's also a link for the QE, how you can create a vertex and the delete vertex, add vertex, like that. So let me come to the Visual Studio. The zoom is good, sir.
Let me check. A little font increase is suggested. Yeah.
Better?
Not better. It's very small. The font size is small enough. It's a bit small. So if you enlarge, yeah, this is good enough. Yeah. If you want, you can also reduce or minimize that sidebar.
Yes.
Whenever you need, and when you need, you can show us.
Okay, so first we are going to cover the step 00, how you can create a Neptune with the Lambda. In this step, what we are just doing, we are just creating our stack folder like we always do. And the main folder, which is our lib folder, we have the lib file. And as you guys know, you have to install all the dependencies to use. I didn't install them, so that's why I ignored this. In this, what we have, this is the EC2 instance and the API gateway. We will look together how we'll build with that, and the Neptune and all other dependencies. So for the Neptune, actually, we need the VPC and we need a security group to provide and secure our database, because Neptune required us to provide those stuff. So first we are creating, after creating our constructor in the constructor, we are creating our VPC, which is a virtual private cloud.
You are speaking very fast, so something my mind is missing. So could be a speak. Your voice is okay. First of all, you have to increase your voice volume a bit more, and please speak or please explain us a little bit slower.
Okay, sir. The voice is good, or
yeah, enough? This is good. Yeah.
Okay, sir. What I'm saying is that in the lab, in the function, we have to, as always, we have to import all the dependencies here. After you just import it and install those dependencies in the constructor, we are providing the VPC. Because in the Neptune, we have to give the VPC. VPC is a simple virtual private cloud. And this, in the short summary, we create a subnet IP4 addresses for our networking. So it's just like that. If someone want to detailed class on the VPC, it's already in the CDK, and the bootcamp 2020, they can watch the VPC class over there. After we create our VPC here, we are providing the EC2. And
so sorry, Awais, disturbing you once again. So let's have a little feedback with our audience that they are following us, because I think that why Awais is going very smoothly, because most of the things already the part of our previous session. For example, the imports, which is already explained many times. The only new thing is that because we are going to using our API gateway and the Lambda function already discussed the API gateway and the AWS snapshot. So Avis, why we are using API gateway? Is this necessary for the AWS snapshot?
Actually, two things new in this repo, what we are going to introduce is the EC2 and the Neptune. The API gateway is used for the creating of an API. It's just for that purpose. And the second step we will see with the AppSync, like we do in the previous classes, when you are using the GraphQL, so you can use the AppSync too for that, for creating your API.
So when we will use the AppSync,
after this is the step 01 after that.
Okay, yeah. So it will replace the API gateway.
Yeah. In that we will use the AppSync.
Okay. So for now, as we are not using AppSync, so that is why we are going to use the API gateway. So fellows, the things is very clear. Whatever things we need to use in our code related to the CDK, we have to import its relevant library code. So that's why it would become easier for us that we can use. So nothing new after that. You can see that the first code that's related to the CDK stack is already discussed many times. The new thing we are going to use, Avis, please scroll down a bit. The security group is already discussed. Yeah, already discussed in previous many times. And
what we are doing in the security group.
Is there anything new in the security group? For example, adding ingress role, which is already discussed. Neptune subnet. Is this new thing, I guess?
Yeah, it is just for the Lambda configuration. Actually, when we just create a VPC and a security subgroup, we also have to define that they both are on the same place where they deploy. So they can, identify the VPC and that there is a Neptune, and in the Neptune we have a VPC and we have a subnet of that VPC network. So you can identify it and deploy it on that and give us our desired result.
Okay, yeah. Can you explain a bit, because I guess that there is something to be explained. You want to say that we need a subnet, a set of API. So API would be belong to same subnet.
Is that? Actually, this is like that. When we are creating a security subgroup, we are ensuring that the Lambda and the Neptune cluster that we are going to deploy is on the same VPC or not. So that's why we have to. Yeah.
Okay, it means we need a VPC. So our all services or functions like Lambda, Neptune belongs to the same VPC. That's why we are creating a VPC here.
Yes, sir.
Am I right?
Yes.
Okay.
Now, after we create a VPC, we create security group here. And in the add ingress rule, actually, this is just adding some more security group for the customization, I guess. I'm right, sir? The ingress rule. Okay, after creating our subnet, we are defining the cluster. It's just like we are creating our DynamoDB. So just like in the Neptune, you have to define your cluster. So in the cluster, as we do, we create a new object with the Neptune.cfndb cluster. In this cluster, we are defining the name. And in that, we are defining the subgroup which we have created here.
Okay.
And in that, yes, sir.
Okay, move on. Finish this point. So I'll ask you a question.
Okay. And now, after that, in the cluster, we are defining that we have a subnet for the Neptune. And in the Neptune, we have a DB subnet group name, which is here. And then there is a DB cluster identifier for the Neptune cluster. And then there is a VPC security group, which we provided earlier, which we have created just. And then when we just done with that, we have a Neptune cluster. In the Neptune cluster, we are saying that you have to depend on the Neptune subnet. So what does that method is doing is if there is any problem in the subnet, it will not trigger and create your cluster here. So it's depend on the Neptune cluster. After the Neptune subnet is provided to the Neptune cluster, then it will be created, and then it will create your cluster on the cloud.
Okay, got it. So actually, we have already created a subnet which is required for our Neptune graph
Cluster.
database. And here we are creating a Neptune cluster. Why am I'm explaining other things? I want to ask my audience, my session fellows, that why there is a cluster added in the Neptune? Why this only Neptune? Why there is we are using calling it as a cluster? Anyone can guess the reason? Anyone?
Because maybe we have more than one instance of the database involved. We are connected with with kind of a master or the main, and there are other replica instances or other connected instances involved. Is it because of that?
Maybe I won't reveal my personal opinion now. Let's see some other provide us any further answer. Anyone participated?
Sir, basically in graph databases, everything is connected with every node is connected to each other, and what we see in cluster is that because of some special properties, some nodes can make clusters. So I think that's why.
Okay, fine. What do you mean by node actually?
Sir, by node, I mean that entity in the database.
Okay. Anyone else want to participate? It Bilal, Ata, Raza. Raza has already spoken. Anyone else? Okay. They are the believing that you both guys saying right. I'm sharing my opinion. Awais or Sarzia suggests us that we are all right or wrong. In my opinion, Neptune database is not a single virtual instance or node or entity, whatever say. It's not a single database. Is a set of database running on different instances of virtual machine. So that's why we are calling it. It's a cluster. Is a set of databases. Number one, and number two. That's why we are using a special subnet. So subnet here for me, subnet means that we are using multiple IPs that are very close to each other. For example, there is a IP one. For example, it's not a real one. For example, an IP is 192.168.0.1, 2, 3, 4, 5, 6. These are continuous ID because they belong to the same subnet. So every cluster assign an IP, internet address, internet protocol address. So because there is a multiple cluster and there is a multiple IPs, so they need to be joined together using subnet. So in DynamoDB, I guess we doesn't need subnet because in DynamoDB, the instance, the node or entity, whatever you say, are a single thing. So that's why the difference between the RDBMS or RDS or DynamoDB and the Neptune. And definitely it is an advantage because we have a multiple cluster. Our data would be insert and retrieve from multiple things. That's it. Over to Awais. I guess Awais, move ahead, please. Sarzia, are we going to a right direction?
Yes, of course.
Okay, thanks, sir.
Okay, after you create the cluster, you have to give the Neptune instance to. What does the Neptune instance is doing is defining the on the cloud. It's saying that what type of configuration you want to run on the cloud, like what memory do you want, what processor you want, what machine you want, in which your cluster will run on that. So here we are defining our cluster, and in the cluster we are defining the class instance class, which is dbt3 medium, because it will charge you when Lambda whenever your Lambda is run on the
Wait, I couldn't hear your
cloud,
last sentences.
it will charge you like that.
It's a blur because of some trouble. Could you repeat the last two sentences?
Yeah, I'm defining this a DB instance class. What
Okay.
this dbt3 medium is doing. Here we are
Okay.
defining the machine on which our cloud on the cloud our cluster will run. So in that it will charge like that. If the size of the machine is increased, so it will charge you the per minutes. There is some dollar on that. So the smallest and the size for that using is the dbt3 medium, because Neptune is not free.
Okay.
Neptune
Fellows,
service is not free.
Yeah.
So when
Fellows,
it's yeah.
Yeah. So I got it, Awais. Fellows, I want to ask other fellows that are they able to get that idea, the instances? Anything need to be clear more?
Yes, there's one question. I get the idea that we are creating the instances and we can create multiple instances. But are they all going to be read-write instances, or is it like we can do read-write write operations on only one instance, but all the others are mainly for read instances? For read query, they work like the replica instances. Is it like this, or all the instances are going to be read-write instances?
Okay, first of all, let's talk about the Neptune instances. This is not talking about the instances that it is about the hardware. Actually, we have already declared that we have a cluster, and the manageability, the instances would be managed by Amazon itself. Here, we are actually going to provide that how our instance would be run. For running a software like Neptune or any service, whatever you say, require a hardware to run. So in Amazon environment, we need some virtual machines, and we stating here that dbt3 medium would be our virtual machine to run our Neptune instances. Now, the question is, your concern is really good. In most of the time when we are using a cluster, we have a single endpoint. Actually, you send your query to a single endpoint and get your data from that single endpoint. But underlying in the endpoint, the cluster as a managed service, it automatically spread your data to a multiple instances or multiple nodes simultaneously. And when you need to write the data, it will also provide us data reading from different cluster. So unlike DynamoDB or RDBMS, where there is a write once and read many, these distributed databases have some multiple write and reading options. So we can also take opinion from Sir Zia and Awais. This is my idea, which I have already shared. Sir Zia?
Go ahead, Awais.
Yes, sir. Yes, sir. You said everything right. And then after creating the cluster and after creating our instance, again, the instances depend on the Neptune cluster. So did you understand that the Neptune cluster is depending on the Neptune subnet? And then there is the instance which is also depend on the Neptune cluster. So they are dependent on each other. If those are there is something wrong, it will not create it on the AWS cloud. After that, we are creating our Lambda function, and in the Lambda function, we are providing our VPC, our security group, and then our environment for the Neptune and Neptune endpoint cluster. And in the subnet, we are providing the subnet settings, which we have just defined over there. And actually, this is the type of the setting of the EC2 subnet type. This is the isolated service. The EC2 actually using for the load balance. So it will again charge you. So we are selecting like that. And here we are defining our Neptune cluster, the output of our endpoint. And here we are creating our API gateway. Using the API gateway, we are creating our API. And this is it. What we have done until now. We create our VPC. And after that, we create our security group and our Neptune subnet. Then what we do is create our Neptune cluster and provide all the subnet group name details, the identifier and the VPC group security details. And provide the Neptune cluster to depend on the Neptune subnet. After we create our Neptune instance here. Then we create our handler for the Lambda function, in which we are just giving all the information like where our code is coming and the VPC and the security group and the environmental variable, which we have just created for our API. Now let's go further to the Lambdas. What we are going to do there.
Aves, sorry, can you make a bit review so everybody understand more specifically? A larger review.
Okay, sure.
Can you explain the things without code, telling what we want to achieve from this code without code? Can you tell it in a story type?
Actually, Rao, you joined in our previous classes? Did you attend our sessions?
Yeah, I'm attending all the sessions.
Okay. So basically what we are doing here, we are defining, because we are working on the CDK, on the code as a cloud formation format. So in here, we are not using any UI for our deployment and other stuff. So we do the code here, and when we deploy it on our AWS cloud, it will automatically create all the services for us. So because
exactly, Sir Wes, kindly, like just a
focus
whiteboard. Yes,
just focus on on whiteboard, or just focus on the Neptune thing. Why we are creating Neptune, or why are we creating API gateways, security groups, or like that? You can draw it on some paint or some whiteboard like thing.
No,
Just create a story.
okay,
Yes,
Rao, actually, let me explain. The things are very easy. Actually, things are very easy. We are a bit confusing. That's why I stop here a bit. That, for example, suppose that there is only one RDBMS or one database server exists. So how could we access that database or that instance? How can we access? We need definitely an IP. Am I right or wrong?
Yes, you're right.
Okay, of course. Now move to the next. For example, if you have two database servers, or take it a 3 database server, in such condition, how many IPs you have or you need?
As many database servers.
Of course. But do you think that these IPs should belongs to or should be similar? For example, if
No,
one IP is,
they should be different, so that we may
should be belongs to the same group. For example, for example, think about that you have a Wi-Fi at your home. So in the Wi-Fi, if you try, even there is a DHCP installed and the IP allocation is dynamic, you will see that the IPs are very much similar and belongs to the same group. Only the last thing would change. This is called, if you are, everyone is aware, if you could remember our college network learning, that in the IP there are two things. One is a network and one is the identification of an instance or of a computer. For example, there are 4 computers so the network portion of that IP would be same, and the last thing would be changed. For example, 192.168.0.1.2.3.4. It means that till the zero, this is the network address, and while the last the octet, if I could remember, the last octet, the last 8-bit represent the computer address. Are you getting what I'm trying to say?
Yeah, or different devices.
All
I'm
different. So
getting.
it means, yeah. So actually, when you need to assign or allocate a complete pool of IP, you need to define a subnet, because we are not using a single IP, we are using a multiple IPs, because we are using a cluster. So we actually, what we are saying, we are providing a subnet to our we are not going to be more detail in the Neptune, but I know that every multi node or multi instance cluster need a handler or need a manager, which actually scale up and scale down when we need more data or more instances, depends on the data we need. So actually, for creating our Neptune cluster, we provide a network address and a subnet. That because of that network address and that's the subnet, it will create a group of IPs, and that IPs would assign to a cluster node individually. So it would be easier for the handler or the resource manager that to call a particular instance or particular node. I guess
So,
you are
there-
getting. So that's why we need a VPC, we need a subnet.
Okay, so
Okay.
there would be a VPC, and then we
Yeah, the subnet actually
when
use. There are two things. Let me clear you. There are two things.
Okay.
One is the subnet, that means that we have a similar or same group of IPs. Network would be same, and computer address would be different. Number one, and the VPC would be same, because if there is a multiple or different VPC, so it would be difficult to communicate each other. So they have to be, the whole cluster have to be in the single virtual private cloud. So the communication would be isolated from the other VPCs and other internet or intranet, and would only available in the inside the VPC. So that's why we need we have to specify the VPC, and also specify that all cluster would be a part of the single VPC and a single subnet. That's it.
Thank you, great.
Sir,
Okay.
basically these things relate to a server room which have different computers, the databases that has a different type of data. Is it this,
Of
sir?
course. Yeah, but thing is that, for example, think about, there is a large server room where is a 2 million computers. It's too much. Let's make it seem small. There are 20 computers, and we want to use only 5 computers. So what would we do? We create a VPC and connect these VPC with the only 5 computers. So the remaining 15 are not going to share the communication for these 5 computers, because they have a different VPC and out of the VPC. And we are assigning the 5 computers a subnet. So it would become a small sub network actually. We have a network which there is a 20 computers, but in the subnet there is only 5 computers. So whenever we send our request, it would be route among these 5 computers. So virtually a 5 computers network is separate from the other 50. Are you getting as per the server room requirement? So if somebody connect to other computers, it won't have connectivity or any relationship with these 5 computers. Bilal, is that clear? Hello?
I think it's clear, Anish.
Thank you, sir. Thank you so much.
So
Plus
does we
that's-
should move on the Lambda, or anyone has any question on the
I just wanted to, Wes, I just wanted to emphasize one thing. Can you show us the code for the Lambda? Go down, not the Lambda. In this, the construct, Lambda construct. Go down. As everyone can see, we are allowing, if we had not allowed this Lambda to connect to that security group and VPC and VPC subnets, look at these things. VPC colon VPC, we have specified the security group. The second is the security group. We have basically VPC subnet. And otherwise, it is all because of security. Otherwise, anybody on the internet can connect to the database. Now, what we are specifying is, unless you are in the same security group with the same, inside the same VPC, you cannot call the database. It is for security purposes. So this is the default behavior of graph databases, that they have a private VPC, which anybody wants to call them will have to be in that subnet with that security. Am I right, Uwais?
Yes, sir.
Exactly. Therefore, it is all because of security. Otherwise, anybody on the internet, if there was no VPC, anybody on the internet can make a direct call to their database. Now, only, yes.
Yeah, sir, one thing I want to clear that I believe that you and Awais or anyone can clear it further, that there is a single endpoint available for the consumer or the user of our Neptune. And that only endpoint is accessible for the anyone who want to access our Neptune cluster. But inside the cluster, the other IPs and the subnet and the VPC would be used. So anyone who want to send that anything for the writing and reading would only accessible to the endpoint. It could not go beyond that endpoint.
Yes, the endpoint is there, but the endpoint cannot be called from outside that VPC and security group.
Okay, fine.
As you can see, when we are setting the environment variable, we are saying natural cluster dot attribute endpoint. We are passing it in the environment variable of Neptune endpoint, the URL. But this URL useless for somebody who is using it outside the VPC.
Okay, this is not a public, you say.
This is not a public URL. Otherwise, it will be a major security breach.
Yeah, of course. So that endpoint would be available only who has an access to that VPC. Am I right?
Exactly. And that security group. Therefore, even the Lambda does not have it, because Lambda will reside in another VPC. Now we are changing the default Lambda VPC, and whatever VPC we created for Neptune, we also are asking the Lambda to work in that VPC.
Okay. So actually now the Lambda is using the VPC that we have used for Neptune. So just because of that, the Lambda is able to utilize or accessible the Neptune.
Yes, exactly. Otherwise, just having the attribute endpoint will not help you.
Okay.
Okay, Wes, let's continue.
I think everything is covered from the lib folder. We should move to the Lambda folder, I think.
Let's move to the Lambda folder.
Okay, to complete our calls to the API which we have just created, we are using the Axios for posting and fetching the data. And we are using some method from the AWS Lambda library, the API gateway method. So if you want to send data or want to fetch some data, you have to use those functions to post, and using the Axios, you have to do it something like that. Now, this is the endpoint which will be given to you when you deploy it on your AWS cloud. So we are just getting that endpoint here. After that, we are telling that what you have to do. You have to do is there is a query language of OpenCipher. We are defining the port of that. This is a default port which is provided from the AWS. And after that, we are giving our query which have to be sent to that URL. Okay. Then, if everything is good enough,
We have
after that,
created could you show us the query again? What we are doing is we have created a person with a label person, an entity with a label person, and with a property age of 25.
yes, sir. And then if you want to fetch something from the Axios, this is something same like that. You have to give it the URL again and give your match query. So as you already study about the queries and the language in which we are saying that you have to match the person which have the age of 25, and after that return the variable of n. In that variable you have to got the age of a person. And after that, we are just getting the response from that and consoling it by the fetch.data.result. This is it from the Lambda function side. This is some try and catch function, just doing like that. Does anyone has any question? If not, I will move to the step 0.
The thing is, at this point, the thing to understand is that you're not opening a connection to the graph database. You will open a query, send the query on HTTP, get a response, and the process ends. If you, in a serverless environment, if you connect a connection, it is very expensive. Therefore, you're just sending a query, getting a response, sending it back to the client, and that's it. It will be more scalable.
Sir, this Neptune endpoint is we are calling that Neptune endpoint in our another application actually.
Yes, we are calling it inside the VPC. We are making the client uses an API gateway to make a call. It calls the Lambda. The Lambda calls the Neptune endpoint, gets the result, and sends it back.
Okay. Now, but the client means there is another application server. For example, a web server reside on AWS or another application server actually, and it's a consumer of that Neptune API. So the web server will receive data from the user over a desktop or a mobile application, and that data will be sent from this application to the Neptune API. Is this that?
Yeah, yes, but you have to understand, if you have calling it directly the database from any other server, that EC2 instance or some other way, you have to be included in the VPC and included in the same security group. Otherwise, you will not, because it is not a public IP address or a public endpoint.
Okay, fine. So this endpoint is restricted in the VPC first of all. So only the application that is a part of the VPC would able to access that endpoint.
Exactly.
That's clear. But it is possible that at some point that we have an application that would have a public endpoint.
Yes, you can have a public endpoint. But the thing is, what you have to make sure is that if you're just like the API gateway is a public endpoint, you will have to pass through the API gateway. Otherwise, it's a bit security. You cannot make you can make the API open, but you cannot make the database URL open.
Okay, fine. It means that, for example, I have a web application. So yeah, in my web application, user, anyone from any area of the world can connect to my web application and send or receive the data. But
Yes.
my web application endpoint available to the user, that's it. The user cannot access further, anything further. But
Yes.
my web application server is also a part of virtual private network and virtual private cloud actually. So it could create call to the Neptune server and get and receive the data.
Yes.
Okay. Is anyone else any question or everything clear? It looks that either people are very much silent or freeze because of this complicated network.
There is a question.
Yeah.
There's a question. We have written 8182 port. Is it a port address specific to
Yeah.
Neptune? Or okay.
It's a yeah. Just to remind you that every database have two things. The one is the port address. So every database has a default port address. You can change the port address, but every database has a default port address. So this is a default port address.
Sir, all the data from these posts, when we post the request and get the data, all data will be static data.
Now you can also give the dynamic data. It's depend on that because for the example, we are providing the dummy data here directly. In the step 01, you can see how we can pass the dynamic data. So from that point, for the step 00, everything is clear. Should we move forward?
Yes.
Yeah.
Let's.
Thank you. So in step 00, we have just seen that how you can create a tune on the AWS CDK using the API gateway and how you can pass your data to the database. Here we are doing in the 01, how we can do it with the AppSync tool, with the AppSync API. Everything is same. The Neptune EC2 Lambda, but now we are using the AppSync for that. To creating our API calls, we will use the AppSync because in that we are using our GraphQL. That's why we are creating the AppSync API for that. So as you guys just see already, how to initialize our API for the AppSync. Here we are just defining and initializing the AppSync API. Then
Awais, is this different than the graph? Oh, sorry, the API gateway.
it is same. It is same. Yeah, it is different with the API gateway because here we are using the GraphQL. So for the GraphQL, AWS provide the AppSync. So to create the AppSync API, you have to create an AppSync object to create your AppSync API. So as we do in the previous classes, as we seen there, how we create our AppSync API and pass our schema folder there, I think that's all the same. The only difference is that in the step 01, in the step 00, we have just seen that how you can pass it by the API gateway. In that step, we are just seeing that how you can pass it by the using the AppSync, using your GraphQL schema. And then we are just creating, after getting the API here, we are initializing our VPC here. Then we are just adding the Lambda layer. For that, it's an optional, it's not a necessary thing. You can just do it or whatever. Depend. Now here we are just initializing our Lambda function. In the Lambda function, there is something changed in there that we are giving it that there is no retry attempt, that do not run it again on the AWS cloud. Just run it one time and there is a timeout. Just run it maximum for the 1 minute because it will charge you. So that's why if you do, for instance, for the testing purpose, in that stack, you will charge around maybe the $10 to $15. And then we are just providing our layers and providing our VPC here. So in here, we are just creating one VPC, and for the one server, we are not doing any subnet and anything. We are just going to say that there is a one user, and for the testing purpose, here we are just passing VPC. Then we create a Lambda data source. In the API, we just provide our Lambda data source, as you all know about it. And then we are creating our resolver. After creating our resolver, we are creating our cluster. As you can see here, there is no security group, so we do not have to define security group. So in the cluster, we are we are just defining our VPC and our instance type. What is the instance type should be? So as I've just mentioned that if you want to try anything, go for the medium one, not for the R5 large. And in the connection, we are just defining the connection type here. And in the Neptune endpoint, we are defining that what the endpoint should be. It is the same like the previous step. And we are giving to the Lambda function as an add environment variable. This is from the lib folder. We create our API. We create our VPC.
So why didn't we edit our security group?
Because we are not providing for the multiple entities. We are just going to say that there is only one IP address, which will be accessed under the Lambda function of the Neptune. So we are just saying there is a one user.
Okay.
Yeah. Then we have just defined our Lambda function, and the Lambda just created. We define our Lambda code here, our name and everything. The thing is that what you have to see there. So if you see on the AWS cloud, and we are just giving the restriction that the timeout should be to 1 minute. So it will not charge you by that, because if it will run again and again, it will charge you of rest. And here we are giving the VPC. Our resolver. After getting the resolver, we define our cluster here. In the cluster, we provide the VPC and the instance type. Then we are just saying that there is an endpoint for our cluster, and we are adding that endpoint to our Lambda function. In the Lambda function, we have created multiple Lambda. As you all see that there is a main handler which will handle all the Lambda. This all steps are same, which we have done in the previous classes. The difference is that how you can create that request to the Neptune. Again, we are using the Axios, and we are providing our process.env Neptune endpoint here, and providing the port and the query language match. Here we in the query, we are just telling that in the query variable we have a match user and the return. We are just defining like that. And when you want to fetch some data, because we are in the all user Lambda, here we are fetching all users. So again, we start that the fetch function with the post request of the Axios, and we give our URL, which we have just defined here. After the URL, we have defined our query, and then we get our data and the result and get the response in a JSON format in the data variable. To fetch all the data, we have just run the for loop for that. And this is how you get the data for that. For creating the data, we are taking the third-party UE library to creating and then ID. This is the dynamic data. Whatever you pass to that parameters, and the data will be stored at like that. So as you can see that in the query, we are creating a user with the ID, which we have just passed from the nano ID, and the name which will be passed from the user.name, which will be passed whatever you pass on the GraphQL side. And then there is an age, which is coming from the GraphQL. This is the dynamic data we are passing to our dynamic data here. Then what we have just do is go and post axios.post, give our URL and give that query, and then return on the username. And if there is an error, console log any error like that. So everything is similar as we've just done in the previous classes. The one thing which is just change is the VPC is included in the Neptune, and the request has been changed, like how you will request the data and save your data to the database. And this is how you create your queries like that. After creating queries, you have to post using the Axios. This is the same method which we are.
Yes, yes.
Yeah, this is the same method which we are just using to delete, update. All the operations are using the same method. Just the one thing is that you have to pass your desired query. So make sure that whenever you pass your query, it will be written in the right format. Like in this, we are deleting this. So what we are doing to do this, go and match the user where ID is this, the dynamic ID, and then detach and delete the variable n. So you have to take care of the query of the open cipher query which you are passing, because if the query is not correct, the operation will not be done. In the get user, we are getting one user with the passing. What we are saying that give the match the user with the ID of this and return the variable of n. And we have just passed this like that. We are doing in all our requests.
Wes, could you show us before we end this thing, the app sync code again, that where we are adding the.
On the lib folder?
Yes.
Actually, first we create our API and define our GraphQL schema here. This is where we are creating our AppSync API. This is the same stuff we are doing already in the previous classes. So it will same, there's nothing change here. After you have created your API, you have to create your VPC. You have to define the VPC for your Neptune. So we are just defining our VPC here. After creating the VPC, the Lambda layer is optional. If you want to do any Lambda layer for your Lambda, you can give it. Otherwise, it's optional. Now, in the Lambda function, all stuff is same from here to here. There. The only thing which is changed is the VPC, the timeout, and retry attempt. We are saying that you do not have to retry again. Because as I just said, the Neptune is not free, so it will charge you. So we are restricting that with the retry attempt formation and the timeout formation, that if the duration, maximum duration of the Lambda should be 1 minute. So we are giving it like that. And then in the Lambda function, we are, as we just do, we are providing our API, our Lambda source. Then we create our mutations and we define our Neptune cluster here. After that, we create our Neptune endpoint, and then we pass our endpoint to the Lambda function. It's like that.
What are we doing in this thing? Allow default port from any IP4.
Actually, say it is defining it for the public access, that if there is any IP4 address, so don't check for the subnet, just access it to the our VPC.
So VPC is open to.
For the security purpose, you have to use the subnet. Okay. Yes. So for the VPC, we have to define our subnet. If you want to make a public access, so it will do it like that. So if any other network IP4 address will come to the VPC, so it will access our VPC and the Neptune database directly.
Okay. Okay.
So yes, if there is anything to add.
Any questions?
Uh, from here, actually, sir, we are creating AppSync, and what would be the AppSync endpoint, and who will use that endpoint?
Anybody who is calling the GraphQL APIs will use that endpoint.
Okay.
You can do it from anywhere.
Again, it would be an application actually.
Yes.
Okay, so the application for now will call might lambda function, and might lambda function will call the Neptune.
Yes.
Am I right? So
Actually,
why not this application directly called to the Neptune? Why we need a lambda function?
It's because there is a security risk. Without proper authentication and everything, we don't want them, the application, to directly call the database.
Okay.
Now, what we are going to do is, Anish, any other question?
No one. Actually, people are quite silent today. Bilal, Faisal, Hamza, what happened?
Is there a way to test this Neptune system locally, like without worrying about the charges? Like, is there anything?
That's a problem. You can't test it locally.
Okay.
Now, because in databases, the main security risk. Now, what we will do is, Wes, please unshare your. What we are going to do is, Anish, are you there?
Yes, sir. Actually, I mute my mic.
Okay. What we are going to do is, from the next class, we are going to start learning SQL. We have learned the graph databases.
Okay.
Now, let me make the case for relational database. The thing is, previously, relational, in the last 30, 40 years, most people were using relational database before cloud came along. But because of the cloud, there was so much load that the relational database were having scalability problems. Therefore, the industry moved towards NoSQL databases like MongoDB and others.
Absolutely right.
But in the last year or two, it has changed. Lot of databases, SQL databases are becoming very scalable. Amazon is also creating a new database, which is calling Aurora Serverless. And its version 2 will be released soon. Therefore, the scalability issues which usually we used to face with relational database are no more. So therefore, in web applications, we can again start using relational database. So therefore, how I see it, in the future, we will be using graph databases for some problems, and for some problems, for some issues, we are going to be using relational databases. And Anish, we are very lucky to have you. Can you tell us a little bit background? What kind of databases have you used over the years and how much experience you have?
Sir, actually, you are absolutely right. Whatever you say, we have already faced in my organization that deal data all around. So this is absolutely right. Every 3 years, in every 3 years, we start facing challenges of scalability in our hardware. For example, we have a server which has a 64 GB RAM 3 or 4 years back, but we need to upgrade the RAM, and the servers has a limitation. For example, our server recently in place do not have capability to go beyond 120 GB RAM, or we cannot add more cores, and we cannot create more space. So this type of challenges we start facing as a RDBMS usage. Plus, when we were talking about the RDBMS, we definitely need to data normalization first, which is sometimes becomes a very extreme challenge because you want to get data and save somewhere. And for the RDBMS, you have to get data and you have to split that data into a very traditional normalization fashion, and which required structuring manner. So, for example, since today, if my application forms or some of application form change, we cannot change our underlying RDBMS data. So for such purpose, GraphQL or NoSQL helping us a lot because they are able to contain or store more unstructured data. We can structure later on, but there is a advantage side also, because if you are going to structure data as soon as possible, the handling of data becomes easier. So we are using NoSQL and we are using SQL. When we have structured data, there is a need of structured data, we definitely go for RDBMS. For example, there's a lot of data that is two-dimensional tabular data in this type of things, and the RDBMS is a great choice where the structuring is already in place. So in my opinion, you actually saying absolutely right that I was 100% agree with you that in recent year everyone around me start that RDBMS is going to be end soon.
But now it has changed. Now in the
Yeah.
last year it has changed because now a lot of like Cockroach DB, Aurora DB, and others have come up, which have made relational databases quite scalable.
Yeah.
Most of the time you are using MySQL or some other database, relational database.
We actually use 2 or 3 database very frequently. One is a MySQL, one is a Postgres, and one is a SQL Server.
Okay. So which one do you like most?
I like Postgres.
Okay. Okay. So therefore, what we are going to do is from next class.
But for me, MySQL or SQL Server is equally easy. Depend upon what do you think that which is easier for our audience.
The thing is, Postgres is the most advanced relational database right now available on Aurora. So therefore, what we'll do is we will start learning, and it will take some time because we will cover normalizing and others. Let's decide on the book just after this class. We are going to, if you are free, we can have a 5-10 minutes chat, and then we'll decide which book to use. And because we are going to start going in depth of SQL and relational databases extensively using Postgres. And once we have become accomplished in using relational database and Postgres, then we will move to the Aurora serverless, which supports Postgres.
Okay, fine.
Okay. Any other questions? So therefore, we are going to start SQL from the next class. Any other questions?
Are we going to use PostgreSQL in the AWS environment, or are we going to also cover like the option of hosting PostgreSQL in our own, let's say, server and then connecting it with the AWS?
Yes. First of all, we'll do it locally so that you can have a lot of practice, and then we will move to the cloud. Faisal?
Sir, can you make a connection
Yes.
of
The
what
thing-
we... Okay.
Yes, go ahead, Rao.
Sir, can you make a connection of our previous class in which we were studying about graph databases and that approach, and with the next approach that we are going to use SQL? database?
Yes. The thing is, for example, if you are using some database, you have kind of database where the relationships are very extensive. Everybody will ask you to, it is wise to use graph databases, but where data integrity is critical and where financial, for example, data is there, relational database are much more secure and powerful as compared to graph database. It depends on the use case. If there are too many relationships, then graph databases are better. But so therefore, when you are developing APIs, you need to have a command of both graph databases as well as, I think we are not going to cover NoSQL databases because what I have found is they are very limiting. They are very scalable, but they are very limiting. For example, in MongoDB, if you are developing a very sophisticated APIs, it is going to, and a business and a model, a data model, it will become, I had faced a lot of problems. So therefore, I always prefer either using relational databases or graph databases for my purposes. So therefore, what we are going to do is teach you, we have already covered relational data, graph databases. And then we are, from the next class, we are going to start covering relational databases.
And one more thing I want to add, Rao, actually, that the RDBMS has a very, very large footprint exists in every organization. So even if you are going to GraphQL for your upcoming application, you have to deal somewhere the RDBMS, because at least 1, 2, or 3 databases every organization using based on the RDBMS. So it's a legacy culture. That's why learning RDBMS is essential, because sometimes you have to at least export data from the RDBMS and re-import data to the GraphQL and transformation, this type of things. So that's why both are very important for us.
Anybody else?
Yes, the question is related to can we have a database hosted somewhere else, and we just use AWS for our main application related to authentication, maybe just S3 bucket and some security services, and host data in our own environment for cost-effective use or something else.
Yes, it is highly possible, but there is an issue involved. The latency will be there, because if you are inside the AWS data center and you are calling from Lambda to the database, the speeds are very high and the latency is very low. But if you go outside the AWS data center, the performance might not be there. Performance will be there, but the latency will be there. You can use it outside, host the database anywhere. It can be done, but it will increase the latency.
Thank you. Thank you.
Rao, actually, one more thing. Here, there another field of data handling exists, which is called ETL, extract, transform, and load. And the recent one is the ELT, extract, load, and transform, actually. So this is actually possible that you have a local or some other instance other than the AWS. In this such concern, you cannot connect actively, as Sir Zia said rightly, because the latency would be very much high, and sometimes every database has a certain time. After that time, that reject your transaction. For example, if there is a 2 seconds exist and your transaction is taking time more than 2 seconds, it will be rejected by the RDBMS. So in such things, you have to extract that data in form of some text file, CSV, JSON, or binary JSON or compressed JSON, and then move data to the Amazon S3, and then re-import into your required databases, either they are a GraphQL or whatever. So you have to extract data from different source, but you have to keep a certain type of storage or your AWS. You can say your AWS would have a data lake where a lot of data sources feeding the data in that data lake, and then you will start extracting and transforming that data for your GraphQL. You have to understand that managing a lot of heterogeneous infrastructure, it would be very tough for us. So we have to emphasize on a single point. For example, either you will work on the Amazon or either you will work on another thing, and try to forget about that you are going to use any local network in future. The future is only cloud based. That's it.
Okay, thank you.
Okay, thank you so much. Anish, we are going to have a teacher meeting. Ovais, we are going to have a teacher meeting as soon as we finish this class. I'm going to share the link, and we'll decide on the SQL path. Thank you so much, everyone. Bye-bye.
Bye-bye.